Today I thought it would be fun to come inside one of the new labs here at Ag Hall to take a look at soil in kind of a different way. Joining me today is Mark Barbadillo, who is also a soil scientist PhD candidate. And I got to know Mark because I've been pursuing my PhD in urban soils, and Mark had this great display as a TA, and I thought it'd be fun for you guys to also see this. So Mark, today we're talking about soil's net negative charge, right?
Yep, absolutely.
So a lot of times I don't think we realize that soil has an electrical charge, but it's really fundamental and important in soil chemistry, right?
Yes.
So let's talk about what you got set up here for us.
So thanks for that, Casey. What we have here are setups mainly to see that the net charge of the soil is negative.
Okay.
Okay, the first one.
So you're going to prove it for us.
I will.
Okay,
Oh, we will, actually.
Okay.
So the first one involves dyes.
Okay.
We have two dyes. Purple one, which bears iron, which have ions that bears positive charge. This one has negative charge. Now, we have a soil.
Okay.
If the net charge of the soil is really negative, and if we add this positively charged dye, what will happen to the leachate?
Well, like
what do you think?
magnets, right? Positive opposites attract. Right?
Yes.
Okay.
So what will happen? Will it be clear or just remain purple?
I'm going to say it's all going to stay in there.
Well, we'll see.
Okay.
We'll see. Okay. So the first thing is, again, we have a soil. We'll make a depression.
Okay.
Okay. Make a depression.
Why is that important?
Well, just to have all the drops go through the soil instead of them going straight to the filter paper and to the funnel, now screwing our
So we know that
setup.
soil is actually filtering, not
Yes,
filter paper.
perfect. So we'll make a depression. We'll add this dye drop by drop until such time we collect a good amount of leachate.
Okay.
This usually takes time. That's why I prepared another setup.
Okay. All right. So we're going to do the same with the opposite
So
color.
we'll do the same thing for our using red dye, which
Okay.
bears, again, negatively charged.
So it should just go right through.
So what will
right?
happen? This one bears, if this one bears negative charge and this one has negative charge, what will happen to the leachate? Will it be clear or just the same?
It's going to be repelled, so I would say it's going to be red.
It's gonna be the same thing. So that's our hypothesis,
Right,
okay?
right.
For now. Make a depression, add this one drop by drop, making sure that the drops hits the soil, not the filter paper.
Okay.
Just like what we did in the previous one.
And you're not adding any water or anything to this.
Nope,
So it's
we're not.
really, you got to add enough drops to actually get some of it.
Yes, we're not adding any water, Casey.
Okay.
And again, this one takes time. That's why I prepared another setup for
Okay.
you.
All right. So
So at the end of
real-
this experiment, this is how it should look like. Look
so-
at this one. This one has the purple dye, which bears positively charged ions. And look at the leachate. It's clear.
It is clear, yeah.
So it's saying that the net charge of the soil is really negative,
So
right?
the positive dye actually stayed in that soil.
Yep, the positive ions or the cations are attracted to the soil, making the leachate appear to be clear.
And the negative dye,
This one is just like the magnet
Right,
thing,
yeah.
you know? Same charge repels, opposite charge attracts.
Right.
It's just like this. That's
Okay.
why we have this still orange leachate.
all right. And so we've got another little setup here with batteries.
So this setup right here is just to complement whatever findings we got from the previous one.
Okay.
Okay, so we have a battery. Battery has positive and negative terminal. We have two wires with metal clips at the end.
Yeah.
We have a slurry. This is just a soil. We've added water,
Okay.
creating a slurry. So what we're going to do is we attach this wire to this negative end of the
Okay.
battery.
Black is negative.
Yep, red is positive. This will usually take 3 minutes or 5 minutes.
Okay.
I prepared this one about an hour ago,
Okay.
so we
it's
can
setting
actually
for an hour.
check. And you do the honor.
Okay,
You
all
do
right.
the honor.
So this is the negative one
Yep.
that we've got here. We're going to pull it out. Not much. A little bit, but not
much. That's
Yeah.
expected.
So negative would repel negative soil.
Yes,
right?
that's expected.
All right. So here is the positive. Oh my goodness.
Look at
Look at that.
There's no trick in that.
It looks like you just stuck it in.
No. That's
clod
legit.
of
That's
mud.
legit. There's no trick in that.
Okay. But it's very uniformly all along the probe there. So, definitely, this is the positive that's been attracted to the negative soil.
Yeah, perfect. So what happened is that it's just like the magnet again. This one is clearly connected to the negative end of the battery. Since this is negative and the soil has a net negative, it's not attracting much soil.
Right.
Not as compared to this one.
Okay. So I keep hearing you say net negative.
Yep.
So does that imply that there might be some positive charges
Absolutely.
in our soil?
Yep. There's some. So the soil bears either positive or negative charge. It's not that. It's just that most soil bears net negative charge.
Okay.
But again, there's still pockets of positive charge in those
So
soils.
those might be.
That's why we
a little
see
bit.
those.
Okay. All right. So overall, though, it is a negatively charged soil that we usually are looking at, especially here in the United States.
Yes.
So why would a gardener care about this, essentially? Because we talk about fertilizing our soil, and it all comes down to a little bit of the chemistry, right?
Yep.
So tell me a little bit about how that plays into the chemistry.
So the thing is, as a gardener, you know, we normally or we almost always add fertilizer to our soil, right?
Right.
And those fertilizers can be positively charged or negatively charged. And knowing that the soil has a charge itself, it has a net negative charge. If we add positively charged, like ammonium-containing fertilizers, for example, you know, your ammonium, since it's positively charged, it will just stick to the soil instead of it being mobile.
Okay, so a great nitrogen source,
Yep.
NH4 plus,
Yep.
right? So a positive cation is going to be attracted to that negative soil. But we also hear about nitrogen runoff and stuff like
Yes.
that, right? Or leaching. into our groundwater. How does that happen?
Well, the thing is, since the soil has a net negative charge and your nitrate as well, which is a good source of nitrogen, has a negative charge, both repels.
Okay.
So it's
nitrate is negative, ammonium is
Yep.
positive.
So it's very mobile in the soil,
Okay.
not as compared to ammonium.
So while you think, okay, nitrogen's important for my garden, it's the form in which it's delivered that also plays into this. Well, Mark, thank you so much. I know this is kind of the fun science behind why we do what we do. And of course, we want to make sure that we're always being judicious when we're using fertilizer in our landscape.
Sure.
Thank you so much.
Well, thank you so much.
We hope you enjoyed this video as part of our Oklahoma Gardening YouTube channel. You can also find even more videos on the OK Gardening Classics YouTube channel. And join us on social media for great gardening tips, photos, and discussion.